So last time we learned a little about the introduction of organic chemistry, the properties of organic compounds, the what are homologous series, and we learned what homologous series are part of the AS and A2 syllabus. Uh, we learned what functional groups are in the sense that they are similar to what they play a similar role to what valence electrons play in groups. So since in groups valence electrons determine the chemical properties, in homologous series the functional group determine the chemical properties of the series, right? So having said that, let's start off with what are some functional groups. So let's start off with the functional groups that are part of your syllabus. And we'll be tackling each homologous series at a time. So the first homologous series that we know is alkanes. Now alkane is a mother family, right? Alkane is sort of a mother family of all organic compounds, right? Because it's simply carbon carbon single bond. So we don't say that there is a particular functional group for alkanes, right? But rest assured that they are a homologous series. It's just that since they are a mother family, they don't have a functional group. So alkanes have no functional group, right? Let's be very clear on this. Secondly, we move on to alkenes, right? So let's see what are alkenes. Alkenes are homologous series that contain the carbon carbon double bond. Okay, any compound containing the carbon carbon double bond has this functional group, is can be called as an alkene, right? One important thing to understand here, and of course, we'll be tackling this when we move on to this topic in further details as well. What is unsaturated and what is saturated? So, carbon, whenever it is attached to four groups, so let's say carbon is attached to, let's say A, it's attached to B, it's attached to C, and it's attached to D, and let's say it can be D and this can be E. Now, it is not necessary for A, B, D, and D to be different. They can be the same as well. But the point of notice here is that carbon makes four bonds to four different groups altogether, right? In comparison, I can give you something like this. So carbon forms double bond with a single bond with B, and a single bond with D, right? Now, in these both cases are different. When carbon has this ability to make four bonds, a maximum of four bonds, it cannot make five bonds with so whenever carbon makes four bonds with four different species, it is known as a saturated compound. So these are saturated. And whenever carbon makes a double bond or a triple bond, perhaps, this will be known as unsaturated species, because the level of saturation, that is the four different groups attached to it with four different bonds, that is not achieved. Since that is the reason it is called an unsaturated compound. So alkenes, for that matter, would make them unsaturated. So all alkenes are unsaturated compounds, right? So let's take an example of an alkene. So carbon bonded with another carbon, and the rest are hydrogens. This is a compound known as ethene, right? This is one of the examples of alkenes, of course. Let's move forward now. So now that we're done with alkenes, let's look at another functional group, that is for haloalkenes. So let's see what are haloalkenes. So whenever a carbon is bonded with this X, where X can be fluorine, chlorine, bromine, iodine, astatine, okay, whatever these elements are part of group 17 of the periodic table, so therefore they are known as halogens. So whenever carbon is bonded with the halogen, it is known as a halogenoalkane, right? But for your particular syllabus, we'll be only dealing with reactions of chlorine, bromine, and iodine. Of course, carbon bonded with fluorine is also a haloalkane or a halogenoalkane. You can call it either way. But the reactions of those compounds are not part of your syllabus, right? So let's say I give you this compound, carbon, double bond carbon bonded with a single bond carbon, then a single bond carbon, right? And let's say this is a chlorine, the rest of them are hydrogens. What you need to do is identify the number of functional groups this compound has. So number one, let's see how many functional groups does this compound have. So let's notice this is one functional group, carbon carbon double bond, and this is another functional group. So there are two functional groups. But you also need to notice that it has carbon carbon single bonds as well, right? So this is a carbon carbon single bond as well. That means that this compound will show chemical properties for alkanes as well, since alkanes are identified by a carbon carbon single bond. So the point to note here is that although functional groups are two, so it will show chemical properties of a halogenoalkane, it will show the chemical properties of an alkene, but simultaneously it will also show the chemical properties of an alkene. So if I were to ask you how many different types of chemical reactions, so different chemical reactions this compound will show, of course they will be three, because it will show chemical properties for alkanes, for alkenes, and halogenoalkanes or haloalkanes, whatever you like, right? So let's move forward. Having said that, now we move on to the next homologous series, alcohols. Alcohols, as you might already know, are compounds that have COH functional group. So a carbon bonded with oxygen and an oxygen bonded with a hydrogen, whenever this functional group is being discussed, this is an alcohol functional group, right? So as simple as that. But I want to make a very important similarity here. I want you to do a comparison here. So water, as you might know, has this structure, right? Water has this structure. Alcohols have this structure. It's oxygen bonded with hydrogen on one side and carbon on the other side, right? The fifth homologous series that I want to tell you about are ethers, right? And just give me a second and I'll connect both of these. Ethers are oxygen bonded with carbon on both sides. Okay? So whenever oxygen is bonded with carbon on both sides, this is known as an ether. So let's say we have an ether here. Are you noticing alcohols, water, and ether? They have very similar structures. The oxygen on all three of them has two lone pairs, and lone pairs might result in some reactions, right? I'm not going into details, of course, right now. We'll be looking them in details when we get to each homologous series and their chemical reactions. But what you need to know is that these three compounds have striking similarities in their structures, and that leaves us with a question that they might have similar chemical properties as well. They might have. So think about it in this way, right? So Next off, we have the sixth homologous series, that is nitriles. Let's look at nitriles. Nitriles are compounds with carbon triple bond CN, right? So whenever we have this functional group, we will call this as a nitrile. Now some of you might have this question, that is 8CN a nitrile? So the answer is no, it's not a nitrile. The reason being, a carbon needs to be bonded with a carbon, and that carbon needs to be bonded with nitrogen, right? And sorry for this, it's a carbon single bond carbon and a carbon triple bond nitrogen. I'm sorry for that. This is the exact structure that it needs to follow. So yes, HCN is not a nitrile. So HCN is not a nitrile. Let's move forward. Let's move on to the carbonyl compounds. What are carbonyl compounds? So carbonyl compounds are essentially of two types. They can be either aldehydes or they can be ketones, right? So carbonyl carbon is a carbon which has carbon double bond oxygen. This is known as the carbonyl group, and this carbon can further form two bonds. So this is known as the carbonyl group. Now, here's one thing. Let's try to understand how carbonyl compounds work. So if on either one of the sides I attach a hydrogen, this would be known as an aldehyde. And if there is no hydrogen on either side and there are only carbons on either side, right, then this would be known as a ketone. So whenever there's a single hydrogen attached to either side, then it's known as an aldehyde. Otherwise, it is known as a ketone. So let's look at example. This compound, this compound would be known as an aldehyde, right? And all of these are hydrogens. And this compound, on the other hand, although it has similar number of carbon atoms, it would be known as a ketone, right? So this is an aldehyde and this is a ketone. So aldehyde because of this and a ketone because of this, right? As simple as that. Now let's move on to the next homologous series. Yeah. So the next homologous series that we'll be talking about are carboxylic acids. But I want you to understand them simultaneously with esters. So we'll be talking about carboxylic acids and esters simultaneously, right? So let's see. So we have this group COO, right? So a carbon bonded with two oxygen, one of them is a double bond and one of them is a single bond. This carbon forms a bond with another element, and this oxygen forms a bond with another element, right? On the carbon side, it can be anything. Similar case for here. On the carbon side, it can be anything. On the oxygen side, however, if it's a hydrogen this is a carboxylic acid. If it's another carbon, it's an ester. Very important difference, very important difference, and I even highlight it. Right? It's a very important yet subtle difference between an ester and a carboxylic acid. Right? This is essentially the entire carboxylic acid group, and this is the ester group. So ester functional group is COO, and carboxylic acid functional group is COOH. As simple as that. Now, next off, another pair of series that I want to actually teach simultaneously are amines and amides. So, amines and amides. Right? So let's learn. If carbon is bonded to nitrogen through a single bond, it is known as an amine. But if this carbon has an oxygen attached to it as well, then it is known as an amide. Now, so this all these three bonds can have anything on them, and this carbon can have anything attached to it as well. More importantly, is what matters is that if this nitrogen has two hydrogens attached to it, it's a primary amine. Similar is the case for here. If this has two hydrogens attached to it, this is a primary amine. But what if this nitrogen has one hydrogen and one carbon? Then it is known as secondary amine, right? Similarly here, it would be known as a secondary amide, right? And thirdly, what if it is attached to no hydrogen? Then it would be known as tertiary amide, and this would be known as tertiary amide, right? Very important yet subtle differences that are important for you to know, right? So let's move forward. The next homologous series that I want to talk about are the acyl chlorides. Check what's their number. Yeah, so 12th series that we'll be talking about, acyl chlorides. So acyl chlorides essentially have a carbon bonded to an oxygen, but this time it has a chlorine attached to it, right? So this functional group is known as an acyl chloride. This can have anything attached to it, but on one side at least there needs to be a chlorine atom, right? Next homologous series that we'll be talking about are arenes. Let's talk about arenes. Arenes have the structure. Of course, the details are not part of your AS level. We won't be talking about this in your AS level, but just know that one of the members of this is benzene, right? Next, we have alkynes, something I should have talked about earlier. Alkynes, because these are on the edge of your syllabus. So alkynes are compounds with a carbon triple bond carbon, and of course these are unsaturated as well, right? So let's take an example of alkynes. So this is one of the example of an alkyne. Hydrogen is attached to complete the valency of carbons. So this is one of the example of alkynes, right? I hope this is clear. So we learned about the 14 homologous series that are part of your syllabus, and we learned their different functional groups. Of course, we'll be going into detail about what they are and how they react and what chemical reactions, what trends do they follow, Of course, we'll be learning them in details. But as an introduction, I hope everything is clear. And if you have any questions, feel free to comment them down, and I'll be sure to address them. Thank you very much. Stay blessed.